Yeah, okay. Let's get started. So, hi everybody, welcome to this joint CMIC WEISS seminar. Today it is dedicated to the presentation of DeepReg, which is a project about deep learning algorithms for image registration, involving many people from our lab and also other labs. Started roughly a year ago, and it came to its first release this week. So I leave the word to Yipeng Hu for the introduction.
Yeah, hello, can you hear me?
Yes.
Yeah, thank you very much. So DeepReg, as said earlier, it started at UCL, and then later it developed into a big team across multiple institutions. And this is a deep learning toolkit for medical image registration mainly. And next slide, please. And as an open source project, the code is held on GitHub and with the documentation on Razor Docs. And we also have a nice landing page on DeepReg.net. So the question comes is that why we need yet another open source project about registration. We have many open source projects regarding medical images already, like MONAI, NiftyReg, Voxomorph. However, for MONAI, it doesn't provide registration methods, and for NiftyReg, it only focused on learning, not non-learning-based classical algorithms. And regarding Voxomorph, their codes are not well tested, and their scope is mainly focused on neuroimaging. Therefore, we would like to provide a toolkit for deep learning-based image registration for research and educational purpose. And the next slide, please. Therefore, we developed the DeepReg, and we also participate in this year the MICA Educational Challenge, thanks to Nina and the other members of the team. We prepared an introduction on learning-based registration method and classical iterative methods to showcase how to use DeepReg, and also served as an educational purpose to introduce registration to people who are not familiar with. And next slide, please. And therefore, this is roughly why we come here with DeepReg, and in the next few slides, different members from the team will present different aspects of DeepReg, starting with Yipeng's background introduction on registration, and then we will discuss several functionalities of DeepReg, and as well as its demos and the testing, and in the end we will describe where it is all going, what's our future plan. And so I give the control to Yipeng. Thank you.
Next slide, please. Thanks. So in October 2018, I gave a CMIC seminar on medical image registration using deep learning. In that seminar, I was trying to review the machine learning-based registration methods for image registration. And in next, please. Next slide, please. In particular, I mentioned there was a trend that before 2017, most proposed algorithms were focusing on to use deep learning to improve individual components of a classical registration algorithms, such as transformation models, similarity measures, numerical optimizations, etc., and making them more efficient and more automated. Around 2017, a class of algorithms that directly predicted deformation or displacement from a given pair of images sort of emerged. I also further classified them into supervised, unsupervised, weakly supervised algorithms. Next slide, please. So this sort of taxonomy was later adopted by a number of review papers in this area. I particularly recommend the first one from University of Virginia and UPenn, and as it is one of the first survey papers that summarized the post-2017 sort of trend very well. Although the title is not very obvious, it's a review paper for medical imaging registration, which I think sort of negatively affected its citation, but this is a topic for another day. Next slide, please. So this is to illustrate the basic ideas of learning-based registration algorithms, where we have a pair of image as network input. Network predicts spatial transformation, and then you have loss functions to penalize the non-smoothness of the predicted spatial transformation, and together with the image similarity measure on the transformed images and the label similarity measure for the transformed labels. And the last 2 years, seeing methods exploring every corner of this illustration. And my citations here are obviously very biased towards our own work. So for example, we have Zach, so points at algorithms using feature-based registration instead of image itself. And we have Chen Ye's work looking at the different ways to sample training data. And we also have different similarity measures coming up, and a different regularization methods on the predicted transformation, or different new transformation models, for instance, 2D to 3D transformation models that involves projective geometry. I'm not even start to talk about the new network architecture designed for registration almost every week. So next slide, please. So I also would like to take a look at those new development from a slightly different perspective. So at the top, above this long arrow, I have sampled a few key papers, by no means comprehensive reviews of the classical algorithms developed from 2 decades ago and possibly 10, 15 years after for classical registration algorithms. And fast forward 20 years and condense them into just the last 3 years, we can see a remarkable resemblance of these older ideas. So we now have seen ways to freeform deformation using based on B-splines and inverse consistency, diffeomorphism, group-wise optimization, all have been tested with the new learning-based algorithms. So the structure, yeah, so the format isn't correct here, but you get the idea. I also use those structure from Jamie's IPME course. For example, I wouldn't be surprised if a version of Demon's algorithms using deep learning, occur in next year's MICI, for example. So next slide, please. So I do not think people are completely running out of the ideas. And without going into too much detail, I'll highlight 2 work here. So the first one is we proposed called conditional segmentation on your left bottom. The proposed conditional segmentation predicts corresponding regions of interest directly without predicting any spatial transformation. So second work is from Tsinghua University and Harvard. So it's called adversarial uni and multimodal stream networks for multimodal image registration. Particularly, I want to point out that they separated spatial transformation and intensity transformation in the multimodal registration task, and the latter of which using the intensity transformation using a direct image-to-image translation method without predicting spatial transformation or regularized spatial transformation. Next slide, please. So my prediction really is I think people will look into the registration algorithm to improve it from a more sort of machine learning perspective, semi-supervised learning, domain adaptation for those inherent problems in limitations of data and labels. To a certain extent, I think a reinforcement learning algorithm may be useful as well to incorporate other sort of empirically available measures of how good the registration is. And time series data model trained with different data or algorithms will be also interesting to look at. And I think this will be looked at because of the real clinical need for registration, especially for a different set of challenges in different areas such as surgery and interventions. And that's for me. Thank you.
Okay, next slide, please. Can you hear me?
Yes.
Yeah, perfect. So let's discuss what's specifically implemented in DeepReg. So what you see here is the high-level overview of the DeepReg pipeline, which can be split into 4 different parts. First of all, we have the input, for which we have a structured dataset, a configuration file, and the documentation that will help us run the pipeline. Then we have the core of the pipeline that consists of the data loader and the model. And finally, we have the output. I will briefly discuss the core, and then later on the Shaheer will discuss the output. So next slide, please. So what's the data loader? The data loader communicates with our dataset and will output 2 images, the fixed and moving image. Next slide, please. We have implemented 3 different types of data loaders that correspond to 3 different types of problems. First of all, we have the paired data loader. This data loader is designed for such problems for which we have 2 different images that will have a similar content but different appearance, and we want to align one to the other. A simple application of that is multimodal studies, for which we have at least 2 modalities for each subject, and we want to align, for example, the CT scan to the MR scan. A second type of data loaders, we have the unpaired data loaders. This loader is designed for such cases where we have 2 images with probably similar appearance but different content, and we want to align one to the other. A simple application of that is, for example, population studies of the brain, for which we have an MR scan for different subjects, and we want to align one to the other. And finally, we have a grouped data loader. This data loader is designed for such cases for which you have multiple images for each subject, normally corresponding to different time points. And the ultimate goal is to align all time points together on a reference space. An example of that is longitudinal studies of the brain, for example. Next slide, please. Okay, so when we have the fixed and the moving image, we will input those to the model. The model can be effectively split into 3 parts. First, the backbone network, then the deformation method, and finally the loss. Next slide, please. The backbone network will be in charge of learning regularities between the images and outputting 3 different feature maps corresponding to the deformation fields of each dimension. We have 3 different types of backbone networks implemented. First of all, we have the 3D unit, for which we can specify the number of filters and the number of downsampling steps. Then we also have the local network from Yipeng, which is an autoencoder type of network, and that it outputs local fields. And finally, we have a global net, which is a specific case of network that will output the parameters of an affine transformation. Next slide, please. So the output of the backbone network will go through a deformation model. We have 3 different models part of the affine transformation that I already mentioned. So the first of all is that the backbone network directly outputs the dense deformation field that will align both images. Then we have a stationary velocity field strategy, for which the backbone network outputs a dense velocity field that we will integrate to a dense deformation field. And finally, we have a conditional strategy for which we predict targeted transformation for regions of interest. And finally, next slide. We have implemented several losses to train our models. First of all, using an unsupervised strategy, we have the image similarity losses, for which we have implemented some of square differences, the local normalized cross correlation, and the normalized mutual information. For weakly supervised training strategies, we have different losses as well, such as cross entropy, mean squared error, dice, the generalized dice, and also the Jacquard index. In this case, we have two different strategies. First of all, a single scale for which we compute the loss or the metric directly on the registered on the images on the label maps. But also we have a multi-scale approach for which we, before computing the metric, we filter the images using a Gaussian filter at different scales, and then we compute the metric at each one of these different scales. And finally, we have a regularization loss to induce a smooth deformation fields. And next slide.
Hi, so currently DeepReg offers 4 command line interface or CLI tools. The first is DeepReg Train. This tool allows the user to easily train a registration network using a configuration or config file, which can be used to specify some options for the network and the training process. So this tool makes it easy to train a network, and it saves checkpoints for the trained network, which allow for the model and its weights to be loaded and used to make predictions for new images. The second tool, DeepReg Predict, offers this functionality. It uses a trained model loaded in using the checkpoint to make predictions for new images. This tool uses a trained network to generate warped images and also produces a DDF or dense displacement field. The DDF itself can be used for warping the images. The third tool, DeepReg Warp, enables the user to use this DDF and use it to warp images. It takes in an image and a DDF and outputs a warped image. So there are a lot of images that are used as inputs or are outputs from these tools. And this is why DeepReg also offers a tool called DeepReg WEISS for visualizing 3D medical image volumes. This tool is able to produce visualizations using the outputs from other tools, like using the DDF and an image to create an animation of warping or visualizing 3D volumes using animations. Next slide, please. So these tools offer different functionalities, but why do we need a command line interface or CLI tools? Well, CLI tools are easy to use without programming experience. They allow for the functionality to be accessed just by entering a single line, and at the same time, they offer flexibility by the use of different arguments. So what do these tools look like in action? Well, here, let's take a look at a simple pipeline. First, we have pairs of images with labels that need to be registered. An animation over the image slices of these image pairs is shown here. You can use these image pairs, which are shown on the right here, to train the registration network using the DeepReg Train CLI tool. The checkpoint that is produced by this tool can then be used by DeepReg Predict in order to generate predictions for new image pairs. The original images alongside warped moving images and DDF are produced by this tool. An animation of the image slices for the images produced is shown on the right here. The original non-warped moving image and DDF can be used with DeepReg Warp to also generate warped moving images. An animation of the warping is shown on the bottom. All these animations are generated using the DeepReg WEISS tool. The demos, which Ester will tell you all a little bit about, demonstrate the functionalities of these tools further. Next slide.
Shaheer. Hi, this is Esther, and I will talk about the DeepReg demos. So if you go to the DeepReg website and then to the Read the Docs page, you will see that in the menu, you have a section called DeepReg Demo. In this section, you will find a large collection of examples showcasing and demonstrating several functionalities of DeepReg. You will find a wide range of applications with real clinical images such as ultrasound, CT, or MRI. It also contains examples using labels or not using labels. Each of these demos provide a step-by-step set of instructions that will allow you to have a better understanding on how to use DeepReg. But also it can serve as a starting point to develop new applications. So the demos follow the same workflow. First, you will have to select the dataset loader, which can be unpair, pair, or group. Then you'll have to configure your training in the YAML file. And then you can either train or tune your network with DeepReg Train or load an already trained model. Finally, you can test or use your train model using DeepReg Predict, which we'll see an example shortly. Now I would like to quickly show all the available demos. Next slide, please. So first, you have example using pair images. Remember that an example of pair images is when you have images from the same patient, but can be different modalities. In this case, we have examples on how to use DeepReg on lung CT, brain MR to ultrasound, and also prostate MR to ultrasound. Next slide, please. Then we also have examples using unpaired images. This is the case, for example, when we need to register images from different subjects. In this case, we have an application to abdominal CT registration, lung CT registration, brain MR registration, and a prostate ultrasound registration. Next slide, please. We also have examples on how to use group images. Remember that an example of a group image registration is for when you have subjects that have several images in different time points. You also have several subjects with similar time points. In this case, we have currently 2 available demos. So one is showcasing a prostate MR case, and another one is with cardiac MRI. In the demos, you will find examples on how to use labels when they are available, and also how to use it in a supervised, weakly supervised, or combined manner. Next slide, please. Finally, we also have a couple of demos showing how to perform what we call a classical registration. For instance, we have a head and neck CT using an iterative affine registration, and also non-rigid registration for prostate MRI. Next slide, please. Now we'll see how to run one of the demos more in detail. So I have selected the unpaired abdomen CT registration. And if you go to the demo page, you will see a set of instructions. So first, you will have to download the data using demo data. Then you can launch the training using demo train and one of the methods, which can be unsupervised, weakly supervised, or combined. Next slide, please. Finally, you can run the prediction using demo predict. You can also load the model if you happen to have one. The demos are designed in a way that should be very easy and fast to get initial results. But if you have problems or suggestions, or you want us to add new demos, please contact us. Next slide, please. Finally, I just want to mention that if you want to run a classical registration, these demos require less steps, as we can see in the example here. You will only need to run the demo data and demo register. And that's all I wanted to tell you about the demos. I will leave you now with Alex, who is going to talk about the documentation.
So if you just click play on the video. Okay, don't worry if it doesn't run. It's a brief sort of looping video that shows me scrolling through Read the Docs, just to give you a sense of how comprehensive.
Can you see
As
the
you
video?
probably guessed from listening, it's just based cap of scrolling through the Read the Docs, the document. The reason why I wanted to show it is because we have worked hard to extensively document everything from our previous, and also because according to an open source survey conducted in 2017, documentation is high, frequently an effective means of establishing inclusive and accessible. With that in mind, the size and complexity of DeepReg, we need reference material. Impressive for anyone. Remember, all of the speakers have said to them already, and especially for inexperienced users who might not know the difference between the EDA or when to use CLI tools versus the AD documentation is key to. So in line with that, who else benefits? Well, it's not just experienced users. Documentation acts as an effective reference tool for intermediate users with an established breakdown of the API, and it also provides guidelines, as you'll hear about later on adapting the code and also on contribute, which benefits the wider community and leverages the expertise of more experienced users. So next slide, please. another challenge thrown up by the open source survey that I mentioned briefly is the fact that incomplete or outdated documentation is a pervasive problem. It's observed by 93% of respondents. In addition to that, 60% of contributors say they rarely or never contribute to documentation. So we're faced with a conundrum. We've got this complex, highly functional code base and potentially a lack of buy-in for actually maintaining current docs that let other people know how to use it to its full potential. So as part of the development process, we've integrated automatic generation of the documentation in Read the Docs from comments written in our code. So this is especially important for supporting the API reference in Read the Docs. Next slide, please. I'm just going to spend the last few minutes of my brief session to give you a quick rundown of what you can find in our documentation. So as a start, we've got an installation guide, and it is as simple as 4 lines of code in Conda to get going. There's also a quick start section, so you can verify your installation. Next slide, please. Thanks. So once you're happy with that, you can then move on to actually looking at implementing some of the demos that Ester has just talked about. And these are a great introduction into learning the functionality of our code. And it gives you a great way to familiarize yourself with all the different behaviors. Next slide, please. Background is also important, and we've got 2 very effective and useful tools for background. In Read the Docs, there's a tutorial section that goes through what was mentioned a little bit earlier, especially by Yipeng and Yongwan. That gives you a sense of what the state of the art is and where sort of DeepReg and its functionality fits into this. In addition, as also mentioned, we've contributed predominantly from Nina and other people in the group by creating an interactive tutorial for the MICI 2020 Educational Challenge. So in addition to just having to actively read a wall of text and read the docs, you can engage with the code and actually learn how it works in the context of a tutorial. Next slide, please. And finally, for people who are either just want to get on and use the code for their own purposes, or people that need a reference when building new models or experiments, we have comprehensive references for the command line interface tools and the APIs, examples of which you can see here. And final slide, please. So finally, of course, we need to ensure that there are contribution guidelines. We have a full system of work laid out for anyone that wants to contribute, and there are a number of different ways to do this, and it's all well documented. So regardless of your level of experience, there is always room to engage with the community, and not just to ask questions, but to also put something back in and to contribute. And that's everything I wanted to say, so I'll pass on to the next speaker.
Hi, thank you, Alex. So you may, after this presentation of the content in DeepReg, you may be wondering still why you should add it to your workflow, or potentially even substitute your own code with the tools that we've presented here from DeepReg. And this is my chance to ask you back, how do you verify if your code is running appropriately and is producing legitimate results? So as we all know, a big part of the job is debugging and combing through scripts to find out why things aren't really working. And at the bottom, we've got a picture of something that probably many people are going to identify with, is that after maybe really long compute jobs, you find out that something wasn't actually working as you thought it was, which wastes a lot of your time and is very frustrating. So next slide, please. So in a sense, I believe most people that actively work with code and medical image registration do some form of checks on their code to verify that it's working appropriately, and it is simple to verify for small instances how things should work. But then the question is, how do you check with a very, very big code base, such as the one with DeepReg, where we have more than 77,000 lines of code, whether it's working properly. Doing this manually is really not feasible. Our team is around 15 people, and obviously they have other things to do as well. We can't ask them to do a full review every week manually. But thankfully, there's a way to do this that saves a lot of time and makes working with this code a lot easier. So next slide, please. We have an automated testing workflow, which is sort of illustrated in this slide with this diagram, where before being able to pass these changes into the main branch of our repository, we ask that the functionality is tested to make sure that it works as intended. So at the beginning, when a change is committed to a branch, we link our code to the server, which runs some tests, and depending on the outcome, so if the tests don't work, it will immediately not be able to be added to our code base. Alternatively, if the tests pass, then we require that the current coverage of the code is maintained such that we can ensure quality of the code and that it continues to work for everybody that uses the tool. So next slide, please. We employ mostly unit tests, but some regression tests too. We test that, for example, our losses work by checking them against some pre-computed values in this upper left, where we see that we have a test to check that the WEISS loss is working. We also check that the code raises failures appropriately if something isn't being used as expected or as designed. And finally, we make sure that the current code works in comparison to the old version of the code. Next slide, please. As you can see, our code coverage, which defines the amount of lines of code in the database which it has been tested, is quite high. It's 99%, but it's not 100%. So we are still working on covering the code and make sure that all of it is tested appropriately, and we are always looking for people to comb through our tests and add more tests as required. So with that, I'm handing over to the next speaker. Thank you.
Everybody, hopefully you can hear me. So people have touched on it a little bit now. I'm going to talk to you briefly about contributing to DeepReg and why you may want to do that and what that can look like. So next here and next again. All kinds of contributions, but you may be asking, why would I want to contribute to, or if you currently are using the project, you can help us improve software that you are using or that you rely on. You can help improve your coding skills. And this can be either with implementation of algorithms and neural networks, sort of as we've done so far, and as Nina's just mentioned, with testing and automation as well. If you're interested in medical image registration, it's a great opportunity to work and discuss and interact with people like us who are also interested in it. And because open source work is all public and it's sort of a lasting impression, an example of your work, and a really great example of that on the next slide, of lasting impressions, is the GitHub archive program, which some of you may have heard about, where essentially they are archiving almost all of the code that they actually that people have put on GitHub, which is open and available in a massive vault 250 meters underground in the Arctic for 1,000 years. It's also being backed up in the Baudelaire library, and Microsoft, since acquiring GitHub, is writing all of this onto quartz glass using femtosecond lasers. I have no idea what that is, but it sounds cool, so I included it on the slide. There's more information that you can find about this, but if you're looking to get involved in, I think has been said before, show your coding skills, improve your coding skills in a public way. Open source is a great way to do that. Next slide. So contributing can be, a variety of different things. And if you're not looking to contribute code, then you can look at improving documentation. I think Matt has created a ticket for, there's some typos that he's found. So that's ticket 496 if you're interested in basically spell checking for us or any of our typos. You can look at creating tutorials, cleaning up issues and helping to organize, or even reviewing pull requests and code that people have done. Or if there's things you'd like to see, you can suggest those ideas. If you are looking to help contribute code, there's tons of open issues. You can ask if you can help somebody with something they're working on, whether it's automation, testing, as Nina has said, creating demos like Esther showed everybody, or just feeling free to come up with ideas and ask us if it would be worthwhile implementing. Those are things you can add as well. Next slide. So if I've convinced you to start contributing, whether it's in a big way or a little way, to the repository, you can start off either at deepreg.net and get your way through to GitHub there. You can check out the guide that's there as well on contributing. To contribute, if you're creating things like maybe you found a bug, you want to request a feature, there's basically lots of ways to get started. As you can see, all these nice big green buttons. And next slide. And if you do wind up contributing, you can get your face shown there on GitHub, and so that can possibly be you. And so if you guys are interested in contributing, I would encourage you to do so. And you can do that either by getting involved directly on GitHub, or feel free to reach out to any of us who we're speaking today, and we'd be happy to push you in the right direction and get you working with us.
Hello, can everybody hear me?
Yes.
Good. So I'm a new member of the DeepReg team, and I'd like to discuss my experience with joining this amazing open source project. So firstly, why did I join DeepReg? Well, I wanted to improve my software engineering skills. Whilst at UCL we're taught how to do research and let's say the background of the research that we're doing. So for example, the machine learning, the theory of the machine learning. We're not taught how to create a good code base, which is easy to read, easy to change, easy to modify if you want to, let's say, add new models or add new functionalities, and also that is easy to run. And unfortunately, this makes your work less valuable because your code is then less usable by the community. So it's much more difficult for the academic community and other students to either re-implement or build upon your work. So because of this, I want to join and sorry. I wanted to join and work on a team that created a good usable code base and improve my software engineering skills. And secondly, I wanted to contribute to a code base that is used by the medical community. DeepReg, as we've been saying, is open source. Anybody can download it and look at the code base itself. Look at how we've implemented the functions, and they can add features or they can use it for their own medical research. And we hope that in the future this might be used by clinicians in the future, or might be built upon by other medical practitioners in their own work. And the third reason I wanted to join DeepReg was because the code base is very well written and the team is very cohesive. Before joining, I looked at the DeepReg documentation, both online and both on the GitHub repo, and I found the documentation very intuitive and easy to follow. And I found the code base very well structured. And in fact, it only took me about 10 minutes to run my first model, which is often not the case when I've been running, let's say, open source deep learning repos. So what have I learned at DeepReg? Well, currently I've learned how to better coding practices, how to improve my formatting, and how to better unit test and use the automated testing facilities available. And this has been done mainly by example, mainly by analyzing how other people have coded and how other people have run unit tests. I've learned how to communicate with the team on an open source project. So software engineering is now quite a mature field with lots of commonly used practices, which include, let's say, discussions on GitHub, meetings and discussing issues, so problems with the code base, or by discussing a feature request, so things we might want to add on the code because they're requested by users. Thirdly, I've learned how to better structure code. When you have a large project, it's important to keep the structure intuitive, easy to follow, and easy to change. This way you can quickly find and modify necessary components. And I found the DeepReg code base very intuitive and very well structured. And hopefully I've been inspired by this for my code in my own future research. Apart from this, there is a small learning curve to DeepReg. However, the team has been very supportive in helping you and making sure that your code is up to standard and that you are communicating in the correct fashion and that you're submitting your code in the correct way. So in my experience, it's been very easy for me to start joining and contributing. So what do I hope to contribute? Well, firstly, I would hope to implement DeepReg and PyTorch. So currently in deep learning, there are two main competing frameworks. TensorFlow, which is, but they're both open source projects, but TensorFlow, let's say, is guided by Google, while PyTorch is guided more by Facebook. And I hope to help implement, maybe in the future date, the DeepReg framework in PyTorch, which at the moment is becoming more popular than TensorFlow. The second thing I could contribute is the low memory version of the networks on offer. So previously I had a paper where we introduced a low memory technique that trades off computational usage for memory. And I would like to provide the user with an option to use these low memory techniques. And thirdly, I hope to integrate, let's say, some of the more state-of-the-art networks or state-of-the-art modules or backbones from computer vision to the DeepReg framework. And that's all for me. Thank you very much.
Hi, this is Matt. So I've been given the task of wrapping up with the kind of deep question of where's it all going, which is a thing I often wonder. So Yipeng has already covered some of his predictions for 2022 and beyond. And I guess in summary, we're thinking about what DeepReg should be. Should we focus our efforts on running around and trying to implement everybody else's algorithm and produce a library of very commonly used stuff? Or should we just use it as a vehicle to publish our research, be very UCL focused? And I think right now it's still up for debate. So I think there's an opportunity there for people who want to contribute and join in to actually join the discussion and shape the future of DeepReg. I think from my experience, I think remaining quite tightly focused and having a small but dedicated team is a great thing. And obviously you can see from the hard work that the team's put in that it's moving forward at quite a pace. And then maybe in terms of where's the project going, I think we can all think about, how do we actually use this project or tools such as this for the benefit of our goals and careers. I mean, we've said before on our teaching programs on the CDT, one of the best ways of just improving your coding is to get involved and fundamentally to get people to see your code rather than hiding away and working on your own. We've also seen in other projects historically how one of the best ways to get citations, to generate impact and to raise visibility of your research is to actually get code that other people can run easily on their computers, and then they can use it and cite you. And I think, again, the advantage of having a local team would be that you actually got this kind of community feel of people working on very similar topics, all geared around registration, and they can give you advice. And obviously some of this has been covered already, and these all build up into essential skills that people are going to need either throughout their PhD as they move into their future career in either industry or academia. So I think I'll just thank the whole team for presenting and say thank you very much for listening, and ask, is there any questions, please, for the whole DeepReg team? Thank you very much.
Thank you, Matt. Thank you, everybody. It was a fantastic presentation. So we have a question from Fernando.
Hello, can you hear me?
Yes, go on.
Yeah, your work is very impressive. Congratulations, guys. It looks great. What's the plan for switching? Why did you choose TensorFlow? And are you planning to switch to PyTorch, as I think Stefano mentioned?
Should I take this?
Yep.
So I didn't choose TensorFlow. When I started, there wasn't a PyTorch, so that's telling. But yeah, so we the history of DeepReg is a bit accidental, really. So it started with me and Yipeng Hu, just two of us, and we just want to get the code to the level which can be shown to others in a less embarrassing way. And then we got Nina joined and then Zach, etc., etc. Then, without knowing, there's a lot of people. So as a team, it's a team effort, and because we had quite a few people interested, we sort of decided to do it properly. So we do have we did discuss probably too many times and whether we should have a version of PyTorch. We basically current idea is we will leave it to, if we do have lots of user requests, we are looking at people who has less experience in coding. To them, the difference between PyTorch and TensorFlow is probably minimum. So that's something I want to point out. Does that answer your question?
Yeah, I think so. Yeah. I guess between TensorFlow 2 and PyTorch, like there's way less difference between TensorFlow 2 and PyTorch and between TensorFlow 1 and PyTorch. So I guess if you wanted to switch, it shouldn't be really.
No, exactly. Yipeng also pointed out, the loader is the same. You don't really need to change it. It's just Python.
I see. Okay.
Yeah, and you're welcome to join and to help with that as well.
I see what I can do.
Great. I think there is a question from Jamie now.
Yeah, thanks. So first, thanks for the great presentation and producing some great software. It looks really good, and I definitely intend to get some of my team trying it out soon. I guess my question is sort of related to your predictions, Yipeng, in a way, but it's how do you see deep learning-based registration in general, and DeepReg in particular, improving on the more classical techniques? So one is obviously once a network's trained, it's going to give you a result faster, which is very beneficial. Are there other ways you see it going beyond what classical ones can do?
Yeah, so I was discussing this very point yesterday with Matt. So to me, first, the faster inference is definitely automatic advantage, as you mentioned. And there are two branches of applications, I would say. The first branch was those ones, intensity-based image registration, automated image registration already worked well. So far, I think if you look around, you got mixed results. Some of the saying the learning-based method still can work better. Obviously, it's learning population statistics. You probably get an edge there. And for the other ones, because the classical method, intensity-based method, already been developed for 2-3 decades, so it's still better. So this one, I think, it's still debatable. Only time can tell. But the other branch, so things like multimodal image registration, historically there wasn't a fully automated, robust method. Now, because of more supervision we can input during training, I think that becomes possible. So deep learning-based method is actually enabling method. So that's definitely a good direction.
Okay. I think so. Just very quickly to comment my view, which I think is what you were saying with your last point. But I think to me, it's the ability to include this extra information in training. So very much, building on your idea of the weekly supervised, we can. So again, I'm thinking of my lung registrations. We have all these landmark points that we use to validate them. We can include that in the training data and actually train it to get them. And I can see that particularly for our difficult lung registrations could really lead to better results than what we're getting at the moment. So that's certainly something I hope to try out in the next year or so, or rather get my students to try out. Thanks.
Thanks.
Okay, we have a question by Danny.
Hi everyone. Yeah, great initiative this, and thanks for the presentation. My question's about kind of translation, I guess, and sort of, specific tools for, user-facing tools rather than development tools that might come out of this. My understanding, and correct me if I'm wrong, that at the moment the environment is sort of largely about development and testing, but at some point, and possibly even now, there are going to be tools that we want to be able to distribute to non-development type users. And so I suppose there's two parts of the question. One is, are there things already embedded in there which have reached that stage? And how do we kind of differentiate the kind of, code tinkering bits, or ready to use bits?
Matt, do you want to take that?
Yeah. I think the first step is to basically make sure code can be run on someone else's computer, and the testing and documentation achieves that. So I would say that's done. The next level, as it were, can it be run by clinicians? I think yes, the command line apps will be there. If you're talking about can it be deployed as a medical application, then the next step would be a program run under research ethics for sort of research purposes only. And again, that can be done kind of as is, but if you want to CE mark something for the purpose of selling it, then you'd be in a position where you would have to provide a piece of software with a specific set of requirements and validation against that. And to do that, you would probably wrap this project. So you would essentially develop a small wrapper, and it would be that piece of software that you're validating, and it would call down to DeepReg, and DeepReg would be what's classified as SOUP, or software of unknown provenance. So DeepReg itself wouldn't be CE marked for any particular purpose because DeepReg wouldn't know what your purpose was. So you would still have to provide that. And I think that's fairly standard. But the fact that it's such a high code coverage and well tested puts you in very good stead to write a very small wrapper. Does that make sense?
Yeah, it does. Yeah. Yeah. So I suppose I'm asking if those mechanisms are in place already to be able to do that, spin out a kind of a specific tool that people can then download and use without having to be experts in the underlying code.
Yeah, so
I guess that's what you're saying.
It can be pip installed and then just run. So, and then your other question was like, which bits are tinkering? There are still some bits in there that probably could be simplified, but essentially the command line tools hide all that complexity so people can just run it. Mm-hmm. Even I can.
Right.
Yeah, this is in line with a question asked in the chat by Hank, who says, as a developer of standardized image processing pipeline, we like software that use not too many parameters, works in most of the cases, like SPM and
On va pub, c'est ça? On va au pub? Oui. C'est pour ça que je suis venu après. Working from home.
Fernando, I think your microphone is on.
Sorry about that.
Yeah. Thank you. Basically, the question is, do do you envision to create specific application versions of DeepReg that doesn't require too much tuning by the user, and you can just apply by their default or preset?
Okay, I'll take that as well. So I think it's more of I would say more of a research question, really. So we know for learning-based method, and some of the applications will be sensitive to learning rate, the bending, the weighting of the deformation regularizer, probably more than the more sensitive than those more established classification or segmentation algorithms. So this, this is largely an open question yet. So without solving those problems, I sort of a universally applicable with a very few parameters algorithm is not possible.
Okay, thank you. And I think for limit of time, we have to end this here. Thank you very much for the contribution, and it was a great talk. And yeah.
Thank you, Marco. Thank you.